All right. Welcome to the third and final part of the spectroscopy lab video. So what I have on screen right now is the report template for the spectroscopy lab, and so hopefully it's pretty straightforward in terms of what it's looking for. You want to essentially replace this green section here with a couple of data tables with descriptive titles, and so this one should be for your red solution, one should be for your blue solutions. This is going to be your lambda max, essentially wavelength versus absorbance data. And then down below here, you want to report your lambda max for each one of those solutions. And you'll be typing this in Word and then just printing this out. And as it states, delete these green sections before you submit. Right here we have the Beer's Law section, so you want to insert a table here with your Beer's Law data, and so that was talked about in the previous videos. These tables will look probably a lot like the ones in your notebooks, but they'll be generated in Word using the table generator in Word. So for example, we can just go here to Insert Table, and we can make whatever sort of table we wish. And so we talked a bit about that in a previous video. And then sort of the new stuff, the new awesome stuff is going to be, we're going to put an Excel graph in here. And so the formatting of that graph is going to be discussed momentarily. But once we have that graph, we're going to use it to find epsilon, and so you want to report epsilon here. And I want epsilon reported to at least 3 sig figs. So let's talk about how we're going to use Excel in order to achieve this. So I've entered some data into Excel, and this is just made up numbers for an imaginary solution, but I'm going to demonstrate this is the type of data you're going to have coming out of lab. So right here I have C, this is going to be our concentration, so I put concentration in the left column, and I have 0 concentration, and that corresponds to 0 absorbance. That's what the A is for. So here's our molarity of one solution, the next solution, the next solution, and so on and so forth. So we have our molarities, and so you're going to want to make sure you record these off the side of the bottle. That's going to be very important. You'll be given these molarities. And then from there we have our absorbances. And so these were recorded via our instrument. So let's go ahead and make a graph out of this data now that we've entered it into Excel. And so we are going to go to Insert, and we're going to choose right here. So we choose the Insert tab, and we're going to click on the XY scatter chart, and we're going to pick the first one on the list, Scatter with Only Markers. Bam. So there we go. There is our graph. So let's blow that up a little bit larger, so hopefully it'll be nice and easy to see in the video. And you'll be sort of formatting this thing and then plunking it down into Word. And actually a kind of a cool feature I want to show you here is that you can expand or contract these cells, and Excel will actually put these things into scientific notation for you depending on if they're expanded or contracted. So just a heads up there that you can change those cells and make them bigger if that's going to be easier for you to work with. So first thing we're going to do here, this is a bit of a pet peeve of mine, is we notice that we have only one series of data. Since we have only one series of data, this legend is completely useless. It just takes up valuable space. And so another thing I'm going to get rid of here is I'm going to get rid of these. And so I did that just by clicking on the series legend on the right side and to hit and delete. I'm going to do the same thing with our scaling right here. So I'm going to click on these horizontal lines. I don't really need these because we're going to use Excel to make the equation for us. So I clicked on the horizontal lines here to select them, and then I hit delete, and they're gone too. So we've really cleaned up and neatened up our graph quite a bit here. But unfortunately our graph's missing some important stuff. And so important stuff that's missing is going to be titles and labels for the axes. So if we go up top here, now that we have the chart here, we have chart tools, we have design, layout, format, things like that. We don't need to get too fancy here. We're going to go to design, and then in the chart layouts, we're going to select the first one listed right here. So the first chart layout, we're going to click on that, and bam, now it's inserted places for us to add titles. And unfortunately, it's undone the formatting changes we did. So let's go ahead and delete those grids again, and we're going to delete our series right here. So now it's getting to looking cleaner. Chart title here, so yours won't be the same, but it might be something along the lines of Beer's Law data, and let's say this is for a green set of solutions. So I'm giving it a descriptive title. And something that's really important to mention here is, because Beer's law can be at a bunch of different wavelengths, what wavelength? And so let's say this is at 720 nanometers, so this is going to be our lambda max for our imaginary green solution right here. And so let's do our axis title down here. So our axis title down here is going to be, this is the axis we control, so this is molarity, so that's our concentration in molarity. And then our vertical axis is going to be labeled with absorbance. And we have a couple options down here. You might also want to change this title. You could also call it something like concentration. That would also be correct. But if we call it concentration, then we need to specify units, and so we'd want to specify either molarity or moles per liter. Something like that. Just make sure it's really clear that the reader knows what they're looking at, and if applicable, the units are absolutely crystal clear to the reader. Alright, so now let's work some magic on this thing. I'm going to click on one of our dots here to select our data series. And now I've selected our data series by clicking on one of our dots. Now I'm going to right click, and we're going to go down after I've right clicked and hit add trend line. And so we want to do a linear trend line, but we want Excel to do the heavy lifting for us here. We want it to do our calculations for us. So we're going to say set intercept to 0, 0. So select that because we have our 0, 0 data point. Display equation on chart, and display R squared value. So I'm showing you the way that I prefer things, though your instructor might prefer, other instructors down the road might prefer something different. So just a heads up there. This is what I like, and some valuable techniques and stuff, but you might want to do something different for other instructors in the future. So what are we looking at right here? So we have our linear equation here, y equals 3414.4x. And so that slope right there is actually our molar absorptivity value here. And sometimes these are very large. They can be tens of thousands or hundreds of thousands, or sometimes they'll be pretty small. This one we can see from our concentration, it's a pretty dilute solution, and yet we have significant absorbance. So what that tells us is that this stuff absorbs light pretty strongly, so we should see a big value there. So if you see a big value, don't be frightened. It might be a small value, it might be a big value. These are really variable. And then the R squared value, what this talks about is how well does our data match the line. So this will actually give us a sense of how good our data was. And so what we'll see is the closer this is to 1, the more accurate our data. And we can tell by looking at this that some of our data points are a little off. It's not perfect, but it's a pretty darn good pool of data. It's pretty close to 1. So you can now cut and paste this graph into your Word document. So that's going to be part of your report there. And we've used this to extract our molar absorptivity constant. All right, congrats. You survived the spectroscopy lab video. Good luck.